So this is our second lesson in the topic Matrices and Transformation. In this lesson, we will learn how to get a matrix of transformation given the object and the image. So we are going to do that using an example. We are told that we have triangle ABC and the vertices are A 2 5, B 2 2, and C we have 4 2. Its image had A prime, which is minus 4 10 minus 10. The other one is minus 4, that is B prime, and the C prime is minus 8 and minus 4. So we are supposed to find out the matrix that transformed triangle ABC onto triangle A prime, B prime, and C prime. So we are going first of all to plot the two triangles. Then from there we identify the matrix that was used to do the transformation. So this is a graph paper that we are going to use. We are going to plot the two triangles on this graph paper. So let's say this is 1. We start from here. Here we have 0, we have 2, we have 4, we have 6. On the negative side, we have minus 2, we have minus 4, we have minus 6, minus 8, minus 10. Then that is our x-axis. Y-axis, we say this is 2, this is 4, that is y-axis. The negative side, we have minus 2, we have minus 4, we have minus 6, we have minus 8, we have minus 10. Let's start with our object. This one, our A is 2 5, so we take 2 there, our 5 is there, so that is where we have our A. Then we have our B, it is 2 2, so this is where we have our B, which is our second point. Then we have C is 4 2, 4 2, that is where we have our C. So that is a triangle that the image, the object. So let's first of all plot that triangle. Then we go ahead and plot the other triangle, the image. So this is a triangle that we have been given, the object. So let's go ahead and plot the image. A is at minus 4, minus 10. So that's minus 4. And this is minus 10. So minus 10, 4 minus 10, that's where we have our point. So this is the image of A. Then B is at minus 4, minus 4. So our B will be there. So that's where we have our B prime, that is the image of B. From there we have the image of C, which is minus 8 minus 4, minus 8 minus 4. This is where we have an image of C. Then we join the 3 points to come up with the triangle, which is the image. Now this is a triangle, the image of that triangle under a certain transformation. And by observing, you can say this is an enlargement. If you count the number of the length of AB, that is 1 2 3 4 5 6. AB here it is 1 2 3. So the length of BC, it is 1 2 3 4. BC, it is here, it is 2. So the triangle has been enlarged twice, but the center of enlargement is the origin, that is at 0 0. At 0 0, that is where we have the center. So the enlargement scale factor is minus 2. minus, meaning that if you draw the triangle has been enlarged on the opposite side of the center of enlargement, which is the origin. If you draw lines from A to A prime, you find that from A to the center is half the length from the center to the A prime, and the same case applies to B prime and B and C prime. So that is how we determine. So this is the enlargement scale factor is equals to 2. So, but we still don't know the matrix that was used to transform, to make, to enable this transformation to take place. So that is what we are going to do. So this is enlargement. From there, for us to be able to get the matrix that was used to transform this, we are going to say that let our matrix be A, B, C, and D. Then if we are able to get A, B, C, and D, then we will be able to get the matrix of transformation. Remember what we said in our first lesson. For we multiplied the matrix by the matrix formed from the object. So we are going to multiply this by 2, 5. That is the column vector of A. Then here we have 2, 2 for B, and we have 4, 2. When you multiply that, what is supposed to give you is the matrix formed from the column vector of the image. So this is minus 4 and minus 10. Then we have minus 4 and minus 4. Then we have minus 8 and minus 4. And this is A, B, and C. And this is A prime, B prime, and C prime. So if we are able to get A, B, C, and D, then we have obtained the matrix of transformation. We multiply this just the way we multiply we multiplied matrices. So we say A times 2, that is 2A, plus B times 5, that will give us 5B. So that is our first column. Then A multiplied by 2, that will give us 2A. We add to 2 times B, that will give us 2B. Then we have A multiplied by 4, that will give us 4A, plus B times 2, that will give us 2B. So that is the first row. We come to the second row. We said C times 2, that will give us 2C. Then we have plus D times 5, that will give us 5D. So C times 2, that will give us 2C, plus D times 2, that will give us plus 2D. And finally we have C times 4, that will give us 4C, plus D times 2, that will give us 2D. So that is one matrix. So we close this bracket. This matrix is equals to this matrix. So we have minus 4, minus 4, minus 8, and then we have minus 10, minus 4, minus 4. And we close the bracket of the matrix. Now, when we are running matrix, we say that because these two matrices are equal, we have an equal sign. Then what we normally say is that the corresponding elements of the matrix are equal. That is 2A plus 5B is equals to minus 4A, and 2A plus 2b is equals to minus 4. That is 2a 2a plus 5b is equals to minus 4, corresponding elements of the matrix. Then 2a plus 2b is equals to minus 4 again. Now we want to eliminate these two forms a simultaneous equation, and we solve them by eliminating a, because we have 2a and 2a, we minus. So 2a minus 2a is 0. 5b minus 2b is 3b is equals to minus 4 minus minus, that changes to positive, so that will give us minus 4 plus 4, which is equals to 0. Divide both sides by 3, implying our b is equals to 0. If b is equals to 0, then you can substitute here in this one equation and say, since b is 0, then 2a is equals to minus 4. 2a is equals to minus 4. Divide both sides by 2, implying our a is equals to minus 2. Fine. So we have managed to get the values of a and b. So let's go ahead and again work the same and get the value of b, c and d. So just like we have done with a and b, we also equate this expression to the corresponding element, which is minus 4. So we say it is 2c plus 2d. No, we are equating 2c plus 5d is minus 10. That is this expression here, and we equate it to corresponding element, which is minus 10. We also do the same to 2c plus 2d is equals to the corresponding value is 4 minus 4. So we close a bracket. We solve these two equations simultaneously. So we subtract 2c minus 2c is 0. 5d minus 2d is 3d. Then we have minus 10 minus minus 4. That will give us minus 6, because minus 4 will change to positive. So we divide both sides by 3, and you find that d is equals to minus 2. So once we get d, we substitute here. So we say 2c plus, now d is minus 2, so it is 5 multiplied by minus 2. That will give us minus 10. So we change that to minus. We say minus 10 is equals to minus 10. We take 10 to the other side. We get 2c is equals to 0. 2c is equals to 0. Divide both sides by 2, and c is equals to 0. So we have obtained the three values that we needed, and that is a, b, c and d. Now, since we had defined our transformation matrix as a, b, c and d, this one, then what we do is we say a, b, c and d, that is our transformation matrix, is equals to, we found our a is minus 2, we found our b is 0, that one, so a, b, that is we have that is 0. Then we found our c, we have found our c is 0, so, and our d, we found it is minus 2. So this is the transformation matrix that was used to transform this figure to this triangle, which you can see even the matrix is telling you. You can see we have -2 there. So that is what we defined as our enlargement scale factor. We said it is negative because it is enlarged on the opposite side of the center of enlargement, which is the origin. So that is how you work out that. So remember, you need to define to give your matrix letters. You can give any letter so long as you are able to follow. You can use A, B, C, D, A, B, C, and D. You can use M, N, R, S, anything that you like, as long as. Then once you are able to multiply and you equate the two matrices which you form from the object and the image, you'll be able to form equations which you solve simultaneously, like that. Then you'll be able to get the values of the elements of the matrix that are used to transform the object. So that is how we get the matrix of transformation given the object and the image. So we are going to do several examples so that you understand how to go about it. So this is our example 2, whereby we are told the following diagram shows a triangle ABC whose vertices are 1, 0, B, 3, 0, C, 3, 3. The triangle A prime, B prime, C prime, whose vertices are A prime, 0, 1, B prime, 0, 3, and C prime, -3, 3, is an image of ABC after a translation. I describe the transformation and its matrix. So the first thing we do is we look at, we observe our two diagrams. So this is the image, this is the object, and this is the image. If you look at A has been transformed from this point, that is 1, 0, to 0, 1. You can say that this is a rotation. The same case applies to B. It has been rotated through a positive 90 degrees. So transformation is a positive 90 rotation about the origin. In which we are saying this is our origin at point 0, 0. Now from there we are required to find the matrix of transformation. That is a matrix that you can use to transform this figure onto our image. Now for us to do that, I said in the beginning, let our transformation matrix be A, B, C, and D. So that is our transformation matrix. Then we say that if you multiply with the column vectors of our object which will form a matrix, you should be able to get the matrix formed from the column vectors of our image. So the matrix that will be formed is 1, 0, we have 3, 0, we have 3, 3. So that is a matrix formed from our object. It should be equals to the matrix formed from the image, and that will be 0, 1, and then we have 0, 3, then we have -3, 3. So that is the matrix. So what we mean here is this is our A, this is our B, this is our C, this is our A prime, this is our B prime, and this is our C prime. So if we will be able to get the values of A, B, C, and D, then we have obtained the matrix of transformation. So we multiply. A times 1 is A, B times 0 is 0. So here you have our A. Then A times 3 is 3A, B times 0 will be 0. So that will give us 3A. Then A times 3, that will give us 3A plus B times 3 will give us 3B. We come to the second row, which will be C times 1, that will give us C. D times 0, that is 0. So here we will be left with C. Then we have C times 3, that is 3C. D times 0, that will be 0. So this will have 3C. Then we have C times 3, that is 3C. Then we have plus 3D. So we close the bracket, and that should be equals to our matrix of the object, which is 0, 1, 0, 3, minus 3, and 3. So from there, you look at our A and B, C, and D. From our matrix, we can clearly say that these two matrices are equal, and therefore the corresponding elements are equal. Therefore, our A, which is here, is equals to 0. So that is direct. A is equals to 0. What about our C? Our C is equals to 1. So we already got C is equals to 1. Now, we say 3A plus 3B is equals to minus 3. And we already know A is equals to 0. So this will mean that 3B is equals to minus 3. Divide both sides by 3. Divide by 3. This means implying that our B is equals to minus 1. So we are left with D. We have already said that our C is equals to 1. So this is 3 times 1, that will remain 3, plus 3D is equals to, this part here is equals to 3. So we take 3 to the other side. We have 3D is equals to 3 minus 3 will give us 0. Divide by 3, both sides divide by 3. It means our D is equals to 0. So we have managed to obtain the four values. That is, our A is equals to 0, our B is equals to minus 1, our C is equals to 1, and our D is equals to 0. So we write A, B, C, and D, which was a matrix of transformation which we had defined, is equals to 0. Our B is minus 1. Our C is equals to where is our C is equals to 1, and our D is equals to 0. So that is a matrix of transformation that was used to transform this object onto the image of this one. So that is how you work it out, and it is very easy. So you look at one more example. So this is an example of our continuation of Matrices and Transformation, lesson 2. And this question, we want to find the matrix of transformation. So we are told that we have a triangle AB, which is, we have A prime. So given the vertices, we are required to find the matrix of transformation. So for us to be able to do, we say, let's assign the transformation as A, B, and D. From there, then we will multiply this by the matrix formed from the vertices of the image, and 5, then we have 9 minus 4, then we have 8 minus, and we close the bracket. When you do this, it is formed by the column vector of minus 4, 9, and minus 3, minus. Remember, this is B and C. This is A prime, B prime, and C prime. So we say A times 5 will give 5A. Then we have B times 4, that will be minus 4B. A multiplied by 9 will get 9A. B multiplied minus 4 will be minus 4B. So you have 9A minus 4B. 8 times 8, you have A. Then B times my B. We come to the second row. Times 5 will give us 5 minus 4D. We have done with the first row. So give us C minus 4. Give it C minus 3. This matrix is equals to our matrix here, which is formed by the vertices of the image, and this will be minus 4, 1, minus 4, minus 5, minus 3, minus 5. That is, these two matrices are equal. We have the line responding are equal. 5 minus is equals to 4, and 9 minus B is equals to more. Equal. Start with the 9 equals to 5A minus B equals to, this is the same as minus 4. From there, these are linear, and we can simultaneously. So we are going 2 from equation 1. We make a, and that we say 9 minus 5A was minus 4B will give us minus 4 plus A, which is equals to 4 minus 4 give us 0. Divide both sides by, we divide by 4, find A is equals to 0. After 5 is equals, we can come and substitute here and say 5 minus 0. 5 times 0 is 0, so minus 4B is minus both minus. So this here, this given, so is 1. So we know values of A and B. Back to our matrices. So this element of it, so it's C minus is equals to minus 5. We have the equals to minus 1. These are linear equations. We also eliminate. So 9, we don't add, but let's subtract. We eliminate 4D minus C will give us 4 minus C will give us 0. That is equals to minus will give us minus. Divide both, I find that minus. After finding, we substitute. This will be in this here minus, that is 5. So we say minus 1 not 5 times 5 minus D equals to minus. We take 5 side positive, so minus 4D is minus 1 plus is equals to minus 4D. to 4 divide by minus, you find that D is minus. Have a matrix of value. So A is D, 2 0, or B is minus 1, D is minus 1, D minus matrix of transformation. So we have come to the end of our second lesson, that is finding the matrix of transformation. But before we wind up, it is important to note that under any transformation represented by a 2 by 2 matrix, 2 by 2 matrix is where we have 2 rows and 2 columns, like 1 0 0 1. That's a 2 by 2 matrix. The origin does not change. If the transformation is a rotation, then the origin, it is about the origin. If it is a reflection, the line of reflection passes through the origin. So that brings us to the end. I hope you have understood. I'll be posting more examples relating to this lesson 2, that is finding the matrix of transformation, so you can understand more about. Do more exercises from your textbooks and you'll be able to get the points that we have emphasized in this lesson.